Hi guys, so today we're going to have a look at exercise 9F and we're going to split it into two videos because there are two very important concepts here. So the first thing we're looking at is the idea of conditional probability. So what conditional probability is the probability of selecting one event given that you already know another event has occurred. So probability of selecting A given you know that B has already occurred. So the effect of this is, while it might not seem to do anything, it actually reduces the sample space for a question. Pretty hard to describe theoretically, but in practice it's quite straightforward once you get the hang of it. So looking at this Venn diagram here, obviously we have 17 in A, 12 plus the 5. We've got 13 in B, and we've got 2 who like neither A or B. So just going through, if we were just finding the basic probability of A, that would simply be the 12 and the 5, which is 17, because that's in the whole, everything in the circle is included in that, out of the whole sample space, which is 27. Can't simplify that. Okay. Now, the notation for conditional probability is the probability of A, and this line down the middle means given. So A given B has already occurred. Okay, so the best way to do this is actually look at the second one. So given that we know B has occurred, so this immediately reduces the sample space to this circle here. So given we know B has occurred, the sample space is now out of 8 and 5, 13, because we know that the event B has occurred. So given that B has occurred, what is the chance of selecting someone who is in A? Well, there's 5 people in the B circle who also like A, so it would be 5 out of 13. Okay, so the conditional probability rule is probability of A given B is equal to the probability of A and B, or the intersection, because that's the part that likes A, all over the probability of, sorry, I made a mistake. Oh yeah, no, probability of B. In fact, I'm actually going to change that to draw. It's a bit simpler there. You can do it either way, so it's the probability of A or B, or you can also think of it as the number of A and B. Either way works. Number of A and B probably just works a bit more simply. Okay, so given that, pause the video now and try and find the probability of B, and then the probability of B given A has occurred. So pause now and have a go, and then I'll go through it. Okay, so what we do here, probability of B, how many are in B? We've got 13 in the whole circle out of the whole sample space, because there's no condition given on this first one. So it's just the probability of selecting B out of the whole sample space. 13 out of 27 can't be simplified, so leave it there. Probability of B given A has occurred is, now we know, it's in this second circle here, so it's reduced the sample space because we know it's out of A. So it's out of 17. And how many of these events, what number is the intersection? How many would like B out of that? Well, it's 5 out of 17. So that's conditional probability. What this also creates, so this is the rule here, which is really important. Put this in your book. Also creates a formula which will be used in the next video, the next concept, called the multiplication rule, okay, for probability. So the multiplication rule is using that rule, but instead having, so remember it could be probability, it could be number, simply multiplying, so the probability of A and B, this one up here, just multiply the number of B up onto the other side, is the probability of A given B times by probability of B. So all we've done there is multiply this side up to here. Okay, and we're going to use this rule in the next piece of work. Thanks, guys.